Which kind of takes us to this next example. Do you see an inside? Do you see an outside? Let me help you to see it, okay? I would imagine, and I hope that you feel like 4x cubed minus 1 is on the inside. Usually people feel like that they can be confident of that, but the outside. When I say that, I'm not referring to the x squared. You guys will actually come to learn, and I'd like you to start to think about it today, that actually is there as a sacrifice. It's going to cancel. So this is not the outside. This is actually meant to cancel. 1/2 square root. That's the outside. Now there'll be a point, maybe that point's already come. Maybe it'll come sometime where you don't have to rewrite it, you just think 1/2. So again, the square root is the outside function, otherwise known as a 1/2 power. What's this whole u thing? The whole u thing is to create a simpler integral. So when I say u is going to equal the inside, when I say u is going to equal 4x cubed minus 1, eventually that's going to get substituted in there. But I have to do this little song and dance over here. I have to do the derivative thing. And yes, you're going to be doing derivatives and antiderivatives in the same problem. So you want to kind of keep it straight. Okay, good news. A lot of times it's a simpler derivative. I hope that you're just bringing the exponent down, but you're subtracting from the exponent, right? Derivatives, you subtract from an exponent. And we do the derivative of this x, and that gives us dx. And I kind of thought of, in case anybody was wondering, it's like you're separating. You're separating the du and the dx. Okay? But really, the reason you're doing that, as you're going to come to realize, is what you really want is you want to solve for dx. You want like a dx expression. So yep, you divide x squared. Yep, you divide 12. I mean, I can write it a little nicer for you as 1/12 x squared. Now, there's two things up here that are sort of just screaming, substitute me. And it always works this way. There's two, we'll call them expressions, that want to get substituted into this integral. And when they do, you end up with something simpler. You end up with something that's going to cancel. And you will pick up on some shortcuts, and some of you will eventually do some of this stuff mentally, but for now, it's a great idea to rewrite anything that doesn't change. So x squared doesn't change. 1/2 is still there. Okay, but 4x cubed minus 1, now that becomes u. That becomes u. And then dx, okay, and you'll find out this is really the heart of the problem. This dx thing becomes this thing. It becomes this 1/12 x squared du. And you'll understand what I mean when you finally get this. And you will. At least that's our goal. You will understand what I mean when I say that the du, or excuse me, the derivative of u, which was equal to 12x squared, that du, obviously it got rearranged, but it was meant to cancel. It was meant to cancel with the rest of the problem. Again, this 12x squared, I know I got it back here, and I know it now in the denominator. But the whole reason that happened was so I could cancel out those x's. Okay, and I'll call that like a cancellation connection. A cancellation connection. And sort of when all the dust settles, out pops a simpler, doable integral. Now here's the other thing. I didn't actually do any antiderivatives yet. Like if you really think about it and you look at where I started and where I am, I've simply changed the way this thing looks. But I did not actually change the function, meaning I did not actually add to the exponent. I did not actually divide by the new exponent. Now, the reason I'm saying that is because you need to do that. You need to do the antiderivative. And that'll also be a step that you'll hear me say again, because that is sometimes forgotten. You do all this stuff over here. I know it looks crazy, but then you never actually change to the antiderivative. So add to the exponent, divide by the exponent. Do a good job with exponents. So, dividing by 3/2 is the same as multiplying by 2/3. Doing good stuff like that can save a lot of pain and suffering. Oops, I actually wrote something slightly wrong. Technically, it's a u. I had an x right there, but technically it's still a u. Okay, because of course that's what I've changed the function into. 1/12 and 2/3, like it or not, you got to do a little bit of simplifying. So basically we get a 1/18, 1/18. But this u, it needs to get turned back into what it equals. It needs to become a function of x. And of course, it's equal to 4x cubed minus 1. So I have 1/18 of 4x cubed minus 1 all to the 3/2 plus c. As I said near the end of the period or the end of the half period, if you check your answer, if you do the derivative, if you go back to where you started, you'll see that it works. Okay, basically 3/2 times 1/18 is going to do a little canceling and simplifying, and then eventually I will do the chain rule, which will be the derivative of the inside, and that's how we end up just with x squared, and of course to a 1/2 power, because I'll subtract from this exponent. Okay, we don't sort of check every problem, but technically every problem will check according to the chain rule. Now we actually, maybe you'll say, hey, sine and cosine, it's okay. Because remember, we're trying to understand, look into the future, that the derivative of u is supposed to cancel with the rest of the problem. So the derivative of sine is cosine. Maybe that's the cancellation connection. How about the derivative of cosine? Well, yeah, it's negative sine, right? Ooh. So this is a problem where we kind of realize that there's some connection between these two. Okay, now, are there some problems where sometimes you learn just by choosing it the wrong way? Yes, there are some. I think I might do one of those. This problem, it's a little more clear that because of this square, that would then say that, okay, this has to be the inside function. Because you've seen this now more than once, that the square is the outside function. So thinking inside outside is a good way to approach a substitution problem. But I'm telling you, when you really figure this out, you're going to say, this is u, 1 plus sine of x over 3. Okay, when you really figure this out, you're going to say that is equal to u because du. du, which we kind of mentioned loosely, the derivative of sine is cosine, okay, is going to cancel with this over here. Now, we got to be careful. It's not just as easy as just saying, hey, they're going to cancel. We got to be careful when we do the derivative. Like, we got to remember how to do the derivative of, the derivative of 1 is 0, but the derivative of sine is cosine. Do you feel like you need to leave the inside alone? You should feel like you're using the chain rule. So I did the derivative of the outside, that's the derivative of sine is cosine, but I left the inside alone, which really is to get us to do the derivative, to do the rest of the chain rule, to do the derivative of the inside. Careful, I know that this right here, the derivative of x over 3, that can stick it to people. How about thinking of x over 3 the same as 1/3 x? Okay, x over 3 is the same as 1/3 x. That should make it a lot easier to do the inside derivative. The derivative of the inside is just going to be 1/3. Okay, I have to admit I forgot, but it's important. Yeah, you need the dx. What is that dx? It's kind of like the du dx. It's that derivative fraction, but it's just split up. So we put dx on the other side. Some of you, it would benefit you to think about the substitution. Some of you, maybe you just need to listen to the teacher again. You're only going to learn this, though, when you actually try to do it. Can you write the new integral in substituted form? I'm showing this modified substitution here. It's kind of like a modified cancellation, actually. If you're wondering what I'm trying to show, these two boxes are equal. That's kind of what I showed in that other problem, but sometimes it's more clear here. Again, I'm just wondering where you're at. Some people say thank you, but no thank you. I decided to only multiply 3 to the other side. I decided to leave it as cosine of x over 3 dx because that's exactly the same as this end of this equation. So that means that I can substitute a 3 du for that entire box. Some of you would have divided by cosine, and those are my students that divided by cosine, then you would have canceled out the cosine. You would have canceled it out. But we're left with a 3 and basically a u squared. Okay, 3u squared. I don't know if you need to rewrite it, but is there anything you want to ask about? We're not done, but do you have any question on substitution? Okay, remember, the whole reason we're doing this is so I can get to something I can actually integrate using a basic rule. That's always what happens here. You turn it into something from yesterday's quiz. So add to this exponent, divide by the new exponent. It was even meant to do some extra canceling. You basically just end up with u to the third power. U to the third power is the same as 1 plus sine x over 3 to the third power. hope you're not sort of hesitant to ask, because I can only help you if I know what you're wondering. Is there anything you want to ask? Try to keep in perspective this thing right here. This thing right here, we're calling it capital F of x, but if I do its derivative, that is, if I go back, I should end up with this problem. And so if I do the derivative, I'm going from the first half of the year, I'm going to do the derivative of the outside, finish the outside, and then don't forget to do the chain rule. That's the derivative of the inside. The derivative of 1 is 0. Oh, I kind of already did it over there, but I'm going to end up getting exactly where I started, noting particularly that the 3's cancel out. And again, that takes me back to the original integral. Most people don't do this, but I'll just point it out. You could type this into the slope field program. I have no idea what it's going to look like. It's probably crazy, but this is like the derivative, and then I could graph this on top of it. It is a nice way to check your work. Some people will do it in a crunch. Again, type that in the slope field, graph this on top of it. Don't worry about the C. All it's going to do is move the graph up and down, but you'll see that it goes with the flow, and you'll see that you're right. Yeah, just stick it over here. Okay, let me give you one to just straight up try. We're not going to make it bonus, or just kind of straight up try as much as you would like. If nothing else, it'll give you a little idea that what you're understanding. Maybe it'll give you an idea of what you still need some help on. Maybe you would like to have a different problem, but I just know that if you actually sit down and start thinking about this, you'll be able to figure some things out. So instead of just listening to me, can you integrate tangent squared of 3x times secant squared of 3x? Okay, now I'm not just going to do the problem, but let's keep learning. It is not uncommon to do that. I might even say I almost expect you maybe at some point to have thought that. It's not right, because when you start to look into the future, you realize that the derivative, it's not like robust enough. Like, there's nothing wrong with the derivative just being a number. We had a problem like that in the beginning of the lesson. But for this problem, you got to look at it and say, there's a lot of stuff up here. Something probably needs to cancel. The reason something probably needs to cancel is because when you have like multiple functions, you're trying to turn them into one u function. Nothing's going to cancel if all I've got is a 3. In other words, that's not going to cancel tangents and secants or whatever function needs to disappear. So we have to do better than that. Do you see a derivative cancellation connection? Like, what if I said to you, do you see a function up here, basically either tangent or secant, because that's kind of like the only thing that's left. Do you see a function up here like tangent or secant whose derivative is kind of like connected to the other one? What's the derivative of the tangent of 3x? Oh, good. You're getting into the details, but the derivative of tangent is secant squared. Okay, you got to figure out how that applies to this problem. If you're like, okay, so what does that mean? It means something with u. If you understand that the derivative of tangent is secant squared, then you understand, or at least I want you to understand, u. I'm going to do something to also encourage you on to greatness here. Okay, I did something which is pretty nice, but I still want you to think about what Colton said. The derivative of tangent is secant squared. It's a good sign that you guys kind of took the hint that you understand that u is tangent of 3x. I actually have to do the problem to kind of think about the final answer. Okay, now be careful. I certainly would never mention a name, but some of you just got to make sure your derivative is right. Be careful. Derivative of tangent is secant squared with the inside left alone. That means it's still 3x times the derivative of the inside. That's the chain rule, times 3. Okay, so 3 secant squared of 3x, dx. I'm really impressed, you guys. You're gonna get this. You have to work at it. Some of you, you're missing a 1/3. Those of you that have the 1/3, you know what I'm talking about. But like your answer is all good. It's just like off by 1/3. By the way, the final answer doesn't even have 1/3 in it. The final answer actually has a ninth in it. I decided to go back to my roots, which was to kind of like solve for dx. Okay, if you just straight up always solve it for dx, it will work. It might be extra work, but you'll be able to get your the rest of the problem to cancel. But you got to see that there's a 1/3 right here. Okay, that 3, it's really not a 3, it's really a 1/3. So now we're staring at the anti of 1/3 u squared. Remember, we didn't actually do the antiderivative yet. That means I never really changed the essence of this problem. The essence of this problem is u squared. But now I'm going to change it. I'm going to change it to be u cubed divided by 3. In other words, 1/9 of our inside cubed. So we can just swap the inside back in there, that tangent of 3x. I would accept that answer. I have to admit that it would, if you got that far, you might as well write it as tangent cubed, like we should put an exponent on a trig function. So 1/9 tangent cubed of 3x. And kind of remember maybe where you started. I saw a lot of you starting with u equal 3x. Remember what I said about that? It's not enough. The derivative is not enough. So we kind of look again at a better u, a better u. It never hurts just to kind of look at your notes. You go to college, professor might not say that, but honestly, before you come back to class, it doesn't hurt to take 30 seconds and just look at what you did. Sometimes it can put you a full 30 minutes ahead just because you're kind of right back to where you were. So are you looking at your examples from yesterday? Are you just kind of refreshing on the substitution method? Okay, we've got this idea that you have to assign u. So that is obviously a big idea. Did you see it in your notes a few places? Let u. Most kids are going to realize that the question becomes, how do I do that? One of the ways that you do that is by letting it be the inside of the function. But again, that's kind of like a beginner's level way to think of it, and it's a good way. But what if there's not an inside? Like what if, like the last problem we did, what if it's like a fraction? So to assign u correctly is to think into the future. I always got confused about Back to the Future. We were going back to the future, but you have to think into the future, which is you have to think about the derivative. Now, I'm being serious about this. When you finally get this, you're going to realize that the whole idea about u is actually more about du. Okay, the whole idea about u is more of a realizing something about du. And what you're going to realize is that du, which is the derivative, cancels with the rest of the problem. So I think this is a good problem to, if you will, prove my point. Let's see if we can integrate this bad boy. All right, what do we have here? All kinds of stuff. 6, x to the 4th, 2x squared, 5. That's all to the 3rd power. And then we have x cubed plus x out there. Okay, what did we sign up for? Well, we're trying to find the antiderivative of this thing. It's going to be a substitution problem. That'll be the next thing that you'll realize, how to know if it's even substitution in the first place. But right now, it's substitution. Now, I know there's a lot up here, but there should be something that catches your attention, this extra function. It's a cubic function. And if that catches your attention as being on the outside, then you should be able to deduce that this is on the inside. But if that's not good enough, which I kind of don't want it to be good enough, you might be wondering what this is all about, and maybe you think that that's on the outside. Okay, I want you to think into the future a little bit. What's the derivative of x to the fourth? Well, it's going to be something x to the third, right? What's the derivative of x squared? Well, it's going to be something with just a regular x. See this out here? Okay, this is meant to cancel. It's meant to cancel with the derivative of u. And basically, it's realizing that the derivative of these exponents is going to line up perfectly with these exponents. Now, if you're saying, yeah, but the numbers aren't all the same, it's just about the exponents that need to cancel, because it's just about the x's that need to cancel. We'll work out the numbers. Let's let u equal this thing. X to the fourth, 2x squared plus 5. We already kind of looked into the future, but we can be a little more exact now. Again, the exact derivative is a 4x to the third, a 4x. Now, technically, that dx needs to be there because you're separating the du and the dx. If you're not really sure why, basically that stands for the derivative of x, which was the derivative of these x's, but it does need to be there. Okay, that right there needs to go. We need to cancel it. It's going to cancel with this. But I want you to notice that we can keep some of this. Like, if we just factor out a 4, some of this is going to stay. Okay, and it's really the 4 that, in a sense, is going to stay. But it ends up, you have to realize, it ends up being shifted over to the other side. Now, if I divide both sides by all of this, which is kind of like how we did it yesterday. Okay, I'm sort of following the rules, if you will. And you can see how this x cubed plus x is now going to cancel with this x cubed plus x. Let's see here how we kind of want to write this. I'm gonna do a little bit of kind of just splitting up. Some of this you might do mentally when you really catch on here, but it is these items, and it's kind of like there's 3 of these items here I want you to see. It's those 3 items that are going to substitute here for dx. Okay, again, the main thing though is that the x cubed and the plus x are going to cancel. Don't be scared to substitute. I'm going to just pause on purpose because I'll give you guys a chance to think a little bit. You should be substituting in 2 places. Don't be scared to substitute. You should definitely be putting the letter U in here. Okay, and then I do substitute each of these 3 items. This is why we did this. This was the goal. It has now happened. We have been able to cancel what we consider the rest of the problem. Another way to say it is we now have a simpler integral. Now, don't lose track here. I still have a 4, which technically is divided, so 6 divided by 4. 3 halves if you want to do that right now, but I'm going to write 6 over 4. I still have this u cubed, and, well, technically this du. But as everything settles out, that thing is much simpler. That thing is actually able to be integrated. To integrate is to actually change the function, to actually do the antiderivative. Again, this sometimes is a step that people forget. They do all this fancy substitution, but never actually do the power rule. So make sure you add to the exponent of 3. Make sure you divide by the new exponent of 4. You know, we want to see u to the 4th over 4. By the way, I changed 6 over 4 to be 3 halves. Okay, but as soon as I change this to u to the 4th, I now have the antiderivative, except it's in terms of u, which is a little weird because I want my answer in terms of x. So we have that sort of that extra substitution at the end of the problem. And that simply is going to be putting u back in. Okay, so we have 3/8 of the x to the 4th plus 2x squared plus 5 to the 4th. Don't forget the plus c makes it more right. Now I know I could stand up here, I could kind of say, do you have any questions? I could say more, but till you really start doing these, will you realize that you get it, which is what we're going to do tomorrow. I do want to say something though, because it is, I'll say, a bit of an alternative to doing all this division. Okay, sometimes people say thank you, no thank you, but sometimes people are like, that actually is easier. Okay, maybe you just want to watch. I'm going to go back to the step where I factored out a 4. And again, you can just kind of look because we had this. It was looking nice right here. Okay, this stuff out here, doesn't that look a lot like this stuff right here? Again, x cubed plus x dx. Let me get rid of the box. That looks a lot like what I'm staring at right here. In fact, the only thing that really needs to be moved, arguably, is the 4. If I divide by 4, I now have I'll say a bit of a cleaner substitution. That is, I certainly can argue that this box, the whole thing, is equal to just this. And what that's doing is it's also canceling these x cubed plus x, but more in a substitution manner. Look, I get to the same place. Some people like this because they realize they get there faster. I get right here a lot faster. All I really end up doing is dividing by 4. I still substituted the u, but all that other stuff just changed out or substituted out to be du over 4. Okay, it's a little bit of a sly way, a sleek way of substituting. I'll point it out again if it seems like that it's helpful to you.